Hey guys, today we're taking a look at step functions. Now, step function is just a piecewise function. It's little pieces of a linear function that look like they're in a series of steps. Now, there's some other names that we refer to these step functions as. Sometimes they're called floor functions, the greatest integer function, the rounding down function. And this is the function f of x is equal to x with these little brackets around it that have feet. Okay, so you can tell this is the floor function because it looks like there's a floor going under the x, and this is always going to be rounding down the value that appears inside those brackets. Now, the other function is the rounding up function. It's the ceiling function, and it's the function that looks like this. F of x is equal to x, but with these funny brackets, and now with the ceiling or the roof on top, and now we're going to take any value inside that bracket and round up. So let's get a little bit of practice here. Evaluate the following, and it looks like we're missing some brackets. We have 6 2/3 that's being rounded down. So we're looking for the integer that we round down, the next greatest integer that we round down to. If we have 6.6, it's got to get rounded down to just 6. In B, we have negative 10.01, and it's also being rounded down. So now be careful with this one. You might suspect it to be negative 10, but it's actually not negative 10 because we're in the negatives. If I round down from a negative, a number that's just over negative 10, I'm actually going to end up at negative 11. So if I round down negative 10.01, I'm going to end up at negative 11. Now, 2 pi is really 6.28. It's going to help us to have that value in there. If we take 6.28, again, this is a number that's just over 6. I'm now rounding up. I'm looking for that next greatest integer, and that's 7. Rounding up 27, well, it's already an integer, so it just stays right there at 27. All right, now let's take a look at the graph of these funny looking functions, okay? We're going to build a staircase, essentially, a piecewise graph. This is the rounding up function, so we're going to take all these values and round them up to the next greatest integer. All right, I'm going to label my xy axis. Here's 1, 2, 3, 1, 2, 3 on the y, and here's our x. And then we'll go negative 1, negative 2, negative 3, and then negative 1, negative 2, negative 3. Okay, now over here in our column, or our chart here, we have the x column. We're going to start with values between 0 and 1. Just because we're going to work in the positives first, that's going to help us to better understand this. Any value between 0 and 1. So let's just take 0.5. If I were to have 0.5 in here and round it up, I would be at 1. Same thing for 0.25. Take 0.25 and round it up, I'm going to end up at 1. 0.01, if I round that up, I'm going to be at 1, so on and so forth, okay? But if I'm at 0, I round up 0, it's going to end up at 0. So the 0.00 does exist on this graph. But as soon as it gets a little bit greater than 0, like 0.01, it's going to get rounded up to 1. So what that looks like is an open circle here at 0 and a straight line until I get to 1, and then a solid line, or a solid dot there at 1. Because if I were to round up 1, I would still be here at 1. But as soon as I go over 1, like let's say I'm at 1.2, it's going to jump up here to 2. So my next little series of staircase is going to open up with a circle, an open circle, a solid line until I get to 2, and then a closed circle. Again, at 2, it's going to be 2. But as soon as I jump above 2, like 2.4, it's going to come up here to 3. So that will be represented by an open circle here at 3 and a solid line all the way until I get to 3. So you can see that we're starting to build this little staircase. This is the rounding up function. Now let's work in the negatives. This pattern actually is just going to continue in the negatives. So if I were to take a value between 0 and negative 1, like negative 0.5, well, negative 0.5 rounded up is going to go to 0. So that's why this will be a solid line between 0 and negative 1. When we get to negative 1, it's going to be an open circle, and then we'll drop down to negative 1 here, a solid line, an open circle, drop down, solid, solid, and open. So you can see the staircase that we're building here. This is a step function. All right, let's take a look at an example that applies the step function to a real-life scenario. Suppose we have a taxi rate. His initial fee is $3 plus 60 cents for each full quarter mile traveled. we want to write a formula, T sub n, for the charge of the trip in m miles. So we're going to let T sub n be equal to the $3 of initial charge plus 60 cents for each full quarter mile. Now, there are 4 quarters in 1 mile, so we need to multiply the number of miles we drove by 4. But we're going to take that value and we're going to round it down because we only want full quarter miles, not parts of quarter miles. Alright, so here's our function that represents that. You notice that we have a rounding down function. And we now want to evaluate this function for 2.9 miles driven. So we'll substitute 2.9 in for n, and that will become 3 plus 0.6 times, 4 times 2.9. And we're going to take that product and round it down. Well, 4 times 2.9 is 11, so we'll have 3 plus 0.6, and we're going to round down, 4 times 2.9 is 11.6. Okay, so we're going to take that 11.6, we're going to round it down now to get to 11. So there was actually only 11 full quarter miles driven in 2.9 miles. So we have $3 plus our 60 cents times 11 now, and this comes out to equal $9 and I have it here, 60 cents. Okay, so there's an example, a real life example of the rounding down function. Let's take a look now at an example of a rounding up function. An errand running service charges us $38 per hour for a full billing hour when any part of an hour is used. So in other words, if they use just 15 minutes, that's a part of an hour, they're going to round up and charge you for that full hour. So we want to find the charge for running errands for 2 hours and 45 minutes. So we have $38, and we are going to round up the number of hours that we are running errands for, and this gives us the total charge. Okay, so $38. In this case, we're going to take that 2 hours and 45 minutes, which is really 2.75 hours, and we are going to multiply that 38 times 3. We're going to round 2.75 up because we're going to charge them for a full 3 hours. That's 38 times 3, and that gives us $114 to run those errands.